Hello, this is Sareen from Exam Help Web. Today I'll be solving Physics Paper 2 AS Level Structured Questions 9702, Paper 2, Variant 3, May June 2020. Starting with question number 1, part A, state one similarity and one difference between distance and displacement. So the similarity is that distance and displacement both have magnitude. And the difference between both of them is that displacement has got direction too, unlike distance, which has only got magnitude. Part B, a student takes several measurements of the same quantity. This set of measurements has high precision but low accuracy. Describe what is meant by part 1, high precision. So how is precision different from accuracy? Precision has something to do with the instrument or the process you're using to get those set of values. And precision is also about the difference in the measurements that you are taking. If the difference is very less, I can say that the values you're calculating are very precise, while accuracy is how close your calculated value is to the true value. So a value of high precision means that there is a small range of values. Because that's the only way the values are going to be closest to each other and the difference between the values will be less. Part 2, low accuracy. So accuracy again is how close your calculated value is to the true value. When you're taking some measurement, you try to take a set of values of those measurements and then you take the average of them. So low accuracy basically means that the average of measurements is not very close to the actual value. Question number 2, part A, state Newton's first law of motion. So this is an object remains at rest or keeps moving with constant velocity until an external force acts on it. Part B, a skier is pulled in a straight line along horizontal ground by a wire attached to a kite as shown in figure 2.1. The mass of the skier is 89 kilograms. The wire is at an angle of 28 degrees to the horizontal. The variation with time t of the velocity v of the skier is shown in figure 2.2. Part 1. Use figure 2.2 to determine the distance moved by the skier from time t is equals to 0 to time t is equals to 5 seconds. So this can be calculated by finding area under the graph within this time interval from t is equals to 0 to t is equals to 5 seconds. Let's divide the figure into a trapezium from t is equals to 0 to t is equals to 3 seconds and a rectangle from t is equals to 3 seconds to t is equals to 5 seconds. Area of this trapezium is going to be half into height into sum of parallel sides. So height of trapezium is this much, so it's 3 into sum of parallel sides. These two are the parallel sides of the trapezium, means 2 plus this is 4.4, 9.6 meters. And the second one would be the area of rectangle, and area of rectangle is equals to length into breadth, where length is 2 seconds and breadth is 4.4 meters per second. So area of rectangle will be 4.4 into 2, which is equal to 8.8 meters. So the distance moved by the skier from t is equals to 0 to t is equals to 5 seconds will be the sum of these distances. So 9.6 plus 8.8, and that gives us the distance covered by skiers at as 18.4 meters. Part 2, use figure 2.2 to show the acceleration is 0.80 meters per second square at time t is equals to 2 seconds. So actually from t is equals to 0 to t is equals to 3 seconds, the line is a straight one, meaning that the acceleration is constant in this time interval of 3 seconds. So acceleration can be any final velocity. Let's take this final velocity at time t is equals to 3 seconds, which is 4.4, and any initial velocity. So I'll be taking the initial velocity as 2, and the time interval for this change in velocity is 3 seconds, and this is how you get an acceleration of 0.8 meters per second square. Part 3, the tension in the wire at time t is equals to 2 seconds is 240 newtons. Calculate the horizontal component of the tension force acting on the skier. So this tension, I'll be labeling it tension 240 newtons, and they are asking us to get the horizontal component of this tension, which is acting towards the right. So the horizontal component of this tension will be cos 28 into 240, and that gives us the horizontal component of force as 211.9 newtons. The total resistive force are acting on the skier in the horizontal direction. So we have the acceleration at time t is equals to 2 seconds, and the force that drives that man forward, and that's tension's horizontal component, that is 240 into cos 28. Resistive force R must act towards his left, as friction always acts against the motion, and his motion is towards the right. So resultant force is equals to mass into acceleration, where resultant force is going to be the difference between the horizontal component of force, which is acting towards the right, and the resistive force, which will be acting towards the left. So 211.9 minus R is equals to mass of the skier is 89, and at time t is equals to 2 seconds, the acceleration was 0.8, and this is how you get the value of R as 140.7 newtons. Part 4, the skier is now lifted upwards by a gust of wind. For a few seconds, the skier moves horizontally through the air with the wire at an angle of 45 degrees to the horizontal, as shown in figure 2.3. By considering the vertical components of the forces acting on the skier, determine the new tension in the wire when the skier is moving horizontally through the air. So while the skier is moving horizontally, its speed remains constant, its velocity remains constant, means it is at equilibrium. There is no resultant force. All the upward force is equal to all the downward forces acting on this man, on this skier. The two vertical forces acting on this skier are his weight, which is acting downwards, and the tension's vertical component, which is acting upwards, since tension is in this direction. While the velocity is constant, its weight will be equal to the other vertical force, which is acting upwards. So this will be tension's vertical component, and that is T sine 45. While its weight can be calculated directly, that it has got a mass of 89 into 9.81 is equals to T sine 45. Now T has got a value of 1234.7 newtons. Question number 3, part A, state the principle of moments. So for this, I can write that for a body to be in equilibrium, or to maintain in equilibrium, its total clockwise moment about a point should be equal to its total anti-clockwise moment about the same point. Means the pivot for both the clockwise and the anti-clockwise moment needs to be the same. Part B, in a bicycle shop, two wheels hang from a horizontal uniform rod AC, as shown in figure 3.1. The rod has weight 19 newtons and is freely hinged to a wall at end A. The other end, C, of the rod is attached by a vertical elastic cord to the ceiling. The center of gravity of the rod is at point B. The weight of each wheel is W, and the tension in the cord is 22 newtons. Part 1, by taking moments about and A, show that the weight W of each wheel is 14 newtons. So about A means that you have to take all the perpendicular distances from A to that forces. The rod is now at rest, means its clockwise and anti-clockwise moments about A are equal. So the forces which are going to cause clockwise moments about point A are this W, and the 19 newtons. While the only force which is going to be responsible for the anti-clockwise moment about point A is the tension 22 newtons. So total clockwise moment is going to be thus: the first W into the perpendicular distance between the pivot point A and this force W is 0.45, plus the weight of the rod, which is 19, and the perpendicular distance between the weight or the center of gravity and the wall is going to be half the length of this rod. So the total length of this rod is 2.6, so it should be half of it, plus the second W into the total distance from W to wall, and that to perpendicular distance is 1.85. This should be equal to total anti-clockwise moment, which is being caused by this 22 newtons of tension, and the total distance from wall to this 22 newtons is 2.6 meters. And this is how you get a value of W as 14.13, which is also equal to 14 newtons. Part 2. Determine the magnitude and the direction of the force acting on the rod at end A. So they're asking you to find the direction and the magnitude of force which is acting on A. It can be either upwards or downwards. So you see that since the bar is in equilibrium state, its total upward forces should be equal to all its total downward forces. So the total downward forces are 19 newtons and the 2 W's, while the upward force is only 22 newtons. So I'll suppose that this one acts upwards. So 19 plus 14 plus 14 should be equal to 22, plus the force at end A, and this is how you get the magnitude of force at A as 25.26 newtons, and this is going to act vertically upwards. Part C. The unstretched length of the cord in part B is 0.25 meters. The variation with length L of the tension F in the cord is shown in figure 3.2. Part 1. State and explain whether figure 3.2 suggests that the cord obeys Hooke's law. So yes, it does obey Hooke's law, as the extension is 0 when force being exerted on that spring is 0. And even if you start taking gradients of this graph, which is force divided by the extension, you will get same value for K, suggesting that it does obey Hooke's law. So I can write that it obeys Hooke's law, and the reason to this is that because extension is 0 when F is 0. Part 2. Calculate the spring constant of the cord. So spring constant can be calculated by using the gradient of this graph. Force constant is equals to force divided by extension. Let's say I'll take the force of 20 newtons, and the extension will be the difference between the new length and the original length, so 0.5 minus 0.25, and that gives me the spring constant as 80 newtons per meter. So spring constant is of 80 newtons per meter. Part 3. On figure 3.2, shade the area that represents the work done to extend the cord when the tension is increased from F is equals to 0 to F is equals to 40 newtons. So our work done on the cord is basically nothing but increase in the elastic potential energy of the spring of the cord. So an elastic potential energy is always half of force into extension. So it's going to be area under the graph from F is equals to 0 to F is equals to 40 newtons. So it's going to be until here, and this is the shaded part. This is the work done to bring the chord to this new length of 0.75 meters. Question number 4. Two progressive sound waves y and z meet at a fixed point P. The variation with time t of the displacement x of each wave at point P is shown in figure 4.1. Part A. Use figure 4.1 to state one quantity of waves y and z that is the same. So it's going to be the time period, which seems to be the same, and you can try to validate that, because time period is time taken for a complete wave. For wave y, it's going to start from here, it's going to finish right here, and for wave z, it's going to start from here and finish right here. So the difference in these 2 points and the difference in these 2 points is basically the time period. So this one over here is 0.75, while this one over here is 3.75. And the difference between them is of 3 milliseconds, and the time period for wave y is 3 milliseconds. And that of z is, again, this is 0.25 and this is 3.25. The difference between 3.25 and 0.25 is also 3 milliseconds. So they have got the same time period. One quantity of waves y and z that is different. So it's going to be their amplitude, because the highest wave z is traveling along y-axis. It's just 2 micrometers, and that on wave y is 4 micrometers. So the difference in their amplitude is of 2 micrometers, and this is what is different between these two waves. So it's going to be their amplitude. Part B, state and explain whether waves y and z are coherent. So coherent waves have got constant phase difference, and I can see that they have also got one. So I can write yes, they're coherent, as they have constant phase difference. Part C, determine the phase difference between the waves when there is time interval on the x-axis and meters on the y-axis. There is some other formula, and when you have distance on the x-axis and displacement on the y-axis, there is some other formula, but both of them, they're quite similar. So to calculate the phase difference, you need to find the difference on the x-axis between the peaks of these two waves. The first peak over here is appearing at 1.75 milliseconds, while that on wave y is appearing on 0.75 milliseconds. So the difference between them is 1.75 minus 0.75, so the difference is of 1 millisecond. And the formula for phase difference is that you divide that difference, 1 millisecond, by the time period of the wave, which is of 3 milliseconds, into 360 degrees. And this is how you get the phase difference. So 1 by 3 into 360 degrees, and you get a phase difference of 120 degrees. If you had distance on the x-axis and displacement on the y-axis, you would have found the difference on the peaks, on the subsequent peaks of both the waves, and divide that by the wavelength of the wave and multiply that again to 360 degrees. So this is the only difference. They both are quite similar. Part D, the two waves superpose at P. Use figure 4.1 to determine the resultant displacement at time t is equals to 0.75 milliseconds. So at time t is equals to 0.75 milliseconds, x, and the displacement of wave y, which is x, is 4 micrometers, and that of wave z is negative 1 micrometer. Hence the resultant is going to be the sum of it. So 4 micrometer and negative 1 micrometer. So 4 micrometer and the sum of it and negative 1 micrometer. and you get the resultant as 3 micrometers. Part E, the intensity of wave Y at point P is I. Determine in terms of I the intensity of wave Z. So intensity is directly proportional to amplitude of that wave and square of it. Intensity of Y divided by intensity of Z is going to be equal to amplitude of Y, which is 4 micrometers, divided by amplitude of Z, which is 2 micrometers square. And since Iy is equals to I, just I, so Iz is going to be I by 4. Part F, the speed of wave Z is 330 meters per second. Determine the wavelength of wave Z. So speed is equals to frequency into wavelength, where frequency is equals to 1 by time period. Time period of wave Z is what? So wave Z has a time period of 3 milliseconds. So we need to also convert that to seconds. So frequency is of 1 divided by 3 into 10 to the power of negative 3 per second. This is the frequency. Now we have the speed and the frequency, which is 1 by 3 into 10 to the power of negative 3 into wavelength, and you get a value of wavelength as 0.99 meters. Question number 5, part A, define the volt. So they're now asking you to define voltage or potential difference. If they had asked you to define potential difference, you should have used resistance into current or something in terms of ohms and current and that. Right now they're asking you to define the volt, means volt, 1 volt they're asking you to define. So there's a formula that energy is equals to current into voltage into time, where current into time is nothing but charge. So energy is equals to voltage into charge, where again voltage is equals to energy by charge, and this is where 1 volt comes. So voltage of just 1 volt is going to be 1 joule per coulomb. Part B, figure 5.1 shows a network of 3 resistors. Calculate the combined resistance of the 2 resistors connected in parallel. So resistors connected in parallel, you take the product, you divide that by their sum. So 300 into 100 divided by the sum of them, and you get a combined resistance of 75 ohms, which is much lower than each of the individual resistors in the parallel combination. Part 2, the total resistance between terminals X and Y. So now this combination of parallel loop is in series with 55 ohms, and total resistance in series is always the sum of them. So it's 75 plus 55, and that gives us the total resistance as 130 ohms. Part C, the network in B is connected to a power supply so that there is a potential difference between terminals X and Y. The power dissipated in the resistor of resistance 55 ohms is 0.2 watts. So the nearer diagram would be like this. This is of 55 ohms. This is of 300 ohms. This is of 100 ohms. They're saying that the power dissipated in the resistor of resistance 55 watt is 0.2 watts. Part 1, calculate the current in the resistor of resistance 55 ohms. So power dissipation is equals to I square R. Power dissipated was 0.2. I is unknown to us, and resistor of that circuit is 55, and you get a current of 0.0603 amperes. Now calculate the current in the resistor of resistance 300 ohms. So this loop over here has a combined current of 0.0603 amperes too, because it's in series with this resistor of 55 ohms of resistance. So current across this should be equal to current across this whole loop. This also means that combined voltage of this loop is going to be the combined resistance of this parallel loop into combined current of this loop. So combined resistance of this loop is what we calculated in the previous part, and that is 75. The current across this parallel connection is equal to current across this 55 ohms of resistor, and you get a combined voltage across this connection of parallel loop, and that is 4.523 volts. Now each resistor will be having this much amount of voltage across the components, because in parallel loops, PD entering the loop is going to be equal to PD in each loop. So now PD across 300 ohms of resistor is 4.523 volts. So current across it will be 4.523 divided by the resistance of it, and the current is 0.015 amperes. But to calculate the potential difference between X and Y, so between X and Y, there is this parallel part, and which has been connected with 55 ohms in series. So total PD across X and Y is going to be the sum across this parallel connection and PD across 55 ohms of resistor. So PD across this loop was 4.523 plus PD across this can be calculated by using the formula R into I, which is 55, into current across it was 0.0603. So the potential difference between X and Y is going to be the sum of PDs across each component. That gives us the potential difference of 7.84 volts. Question number 6, the current I in a metal wire is given by the expression current is equals to A into N into V into E, where V is the average drift speed of the free electrons in the wire and E is the elementary charge. But A, state what is meant by the terms A and N. So A is the cross-sectional area of that metal wire, while N is number density of electrons in the wire. And N is usually 1 by the volume. Part B, use the above expression to determine the SI base units of E. Show your working. So E is equals to current divided by cross-sectional area into number density into average speed velocity. Current is in amperes, area is in meter square. N is 1 by volume, means 1 by meter cube, so it's going to be per meter cube. Average drift speed is in meters per second, so this is going to be amperes into per meter square into meter cube into per meter seconds. So this is equal to ampere second. Part C, two lamps P and Q are connected in series to a battery as shown in figure 6.1. The radius of the filament wire of lamp P is twice the radius of the filament wire of lamp Q. The filament wires are made of metals with the same value of N, means same number density. Calculate the ratio average drift speed of free electrons in filament wire of P and average drift speed of free electrons in filament wire of Q. So average drift speed is equals to current divided by N, A, and E. When P has double its area, its average drift speed will decrease by 4. Remember, when radius increases by 2 means area also increases by 2. And area is always squared, so this quantity will decrease by 4 because average drift speed is inversely proportional to area. So now the average drift speed of free electrons in filament wire of P is 1 by 4 and that of Q is just 1. So 1 by 4 divided by 1 gives you a ratio of 0.25. Question number 7. A potential difference is applied between two horizontal metal plates that are a distance of 6 millimeters apart in a vacuum as shown in figure 7.1. The top plate has a potential of negative 450 volts and the bottom plate is earthed. Assume that there is a uniform electric field produced between the plates. A radioactive source emits a beta negative particle that travels through a hole in the bottom plate and along a vertical path until it reaches the top plate. Part A1. Determine the magnitude and the direction of the electric force acting on the beta negative particle as it moves between the plates. So electric field strength is equals to force divided by charge. Electric field strength also is equal to voltage divided by the distance between the plates. So force is equals to voltage into charge divided by the distance between the plates, where voltage in our question is of 450 volts, the difference between these two values. It's of 450. The charge for a negative beta particle is of 1.6 into 10 to the power of negative 19, and the distance between the charged plates is 6 millimeters, which is equal to 6 into 10 to the power of negative 3 meters, and you get a magnitude of force as 1.2 into 10 to the power of negative 14 newtons, and this is going to be vertically downwards. Since beta negative particle is negatively charged and opposites always attract, among negative 450 and 0 volts is more positively charged. But to calculate the work done by the electric field on the beta negative particle for its movement from the bottom plate to the top plate, so work done is equals to electric force into the distance it moves in the direction of force. The electric force was of magnitude of 1.2 into 10 to the power of negative 14, and the distance it covers is 6 millimeters, which is equal to 6 into 10 to the power of negative 3 meters, and you get a work done of 7.2 into 10 to the power of negative 17 joules. Part B. The negative beta particle is emitted from the source with a kinetic energy of 3.4 into 10 to the power of negative 16 joules. Calculate the speed at which the beta negative particle is emitted. So kinetic energy is equals to half mass v square. Kinetic energy is of 3.4 into 10 to the power of negative 16 equals to half mass of beta negative particle can be taken from the data booklet, which is of 9.11 into 10 to the power of negative 31 kilograms into speed square, and you get a speed of 2.7 into 10 to the power of 7 meters per second. Part C. The beta negative particle is produced by the decay of a neutron. Part 1 complete the equation below to represent the decay of a neutron. So this is part of your syllabus. You need to learn the decay of a neutron as well as proton. Decay of a neutron will give you beta negative particle along with a proton and an antineutrino, which has got 0 charge and 0 nuclear mass. Part 2. State the name of the group of particles that includes neutrons. So hadron is the group which contains neutrons, and the group which contains beta negative particles is leptons. So we are done with this paper. Thank you for watching.